Josie begins sample preparation by applying a piece of double-sided carbon tape to a 50mm stub and carefully trimming the edges. The carbon tape is sticky and allows the samples to be planted firmly on the stub. The tape also acts as a conductive contact between the sample and the stub. It is one of several steps taken to ensure that minimal charging will occur. Charging is what frequently causes images from the SEM to appear fuzzy, too dark, or too bright. This distortion is produced by a buildup of electrical energy in a specimen. While placing samples on the stub, Josie uses a dissecting microscope to ensure that she is positioning them in the most optimal orientation. Josie also applies colloidal silver paint, which is very conductive, between a portion of the sample not to be viewed and the carbon tape, to ensure that there is a continuous electrical connection between the sample and the stub. The final step before our samples can be placed into the SEM is to deposit an ultra-thin layer of metal onto the surface of the entire stub using the sputter coater. Unlike the silver paint, which can cover and obscure fine details of the sample that we might want to see, the layer of metal is so thin and fine we won't even know it's there. We use an alloy of gold and palladium, just a few nanometers, billionths of a meter, thick, providing the conductive coat that allows the sample to discharge the energy from the electron beam to the silver paint and on through the carbon tape to the aluminum stub. The sputter coater first removes all the room air from the chamber. Then it replaces it with a small amount of argon gas. When we turn up the current in the chamber, the argon gas begins to glow a pale bluish-purple color in much the same way as a neon sign. The argon gas is ionized, and the argon ions knock atoms of gold and palladium from a thin foil target at the top of the chamber. The sample is rotated within the chamber because although the argon ions bend the paths of the gold-palladium atoms, the gold-palladium is generally deposited straight onto the specimen from above. Thus, just like you would get a suntan only on one side if you were to lie out in the sun on your back, the sample would not be evenly coated unless it was rotated and tilted during the coating. Once the sample has been coated for about a minute and a half, we turn the sputter coater off and wait for the chamber to backfill with room air. When the chamber comes to atmospheric pressure, Josie can open the sputter coater lid and remove the stub. The coating is just thick enough that the specimen and stub appears to the naked eye to be a dull gray or silver metallic color. The stub is now ready for Josie to load into the microscope. Even when it is not being used, the scanning electron microscope, including the specimen chamber, is kept under vacuum. This means that Josie must first vent the specimen chamber so that she will be able to open the door and place the sample stub inside. While the microscope is venting, Josie switches on the CCD camera so that she can see the interior of the scope. It takes several minutes to vent, and when it is done, Josie is able to easily pull open the door. She carefully unscrews the sample that was previously being viewed and sets it aside. Josie then places the new sample stub in the specimen holder and screws it into place. Next, making sure that the stub will not bump into the column, Josie closes the door and turns on the pump. After a few minutes, the chamber has been pumped down, and it's time to turn on the electron beam. Now the microscope is ready to operate.